This video is going to go over the problem from page 24 of the Big Gold Free Response Packet and how to score it. Okay, so the first one gave us the velocity in feet per second of a skydiver. After parachute opens, her velocity satisfies that differential equation and that initial condition. So your first point comes from making sure you have separated the variables correctly. Now how you would have to do that, because remember we have two terms here on the right side and we have a term on the left side. We need to just get two terms. So you want to factor, then you can divide by v plus 16. And then one thing I keep mentioning is if there is a scalar like the -2, keep it away from what you're solving for. So we're trying to solve for v, so that -2 we want to put away from that. And then what we can do, so we get a point for that separating. If you don't separate those correctly, I don't believe they give you any more points for this part of the problem. So it's really important that you do that. Then you can integrate both sides. Okay, how they give points for that? They actually give you a point for integrating the left side correctly. They give you a point for integrating the -2 dt correctly. And then they give you another point for the plus c. So you could earn 4 points there. Okay, one for the separating variables, and then one for integrating the left side, one for the right side, one for the plus c. Then you're going to get another point for solving. So you have to exponentiate both sides, and then once you get v equals c e to the -2t minus 16, then you can give yourself another point. And the last point comes in for putting in that initial condition of 0, -50, and finding the c value. So when you plug that in, you'll get c is -34. So your last point on part A is v of t is -34 e to the -2t minus 16. Part B is just worth a point. They want us to find terminal velocity, which means the limit as t approaches infinity of the velocity function. So if I do that, finding the limit as t approaches infinity, I could probably think about it this way a little bit easier, because if t is infinity, that denominator is going to be 0 of this first part, and then we have minus 16, so our terminal velocity will be -16 feet per second. You could also think about that graphically, although it's a non-calculator question, so you'd have to think about it without your calculator. Part C wants to know, is it safe to land when her speed is 20 feet per second? Okay, so if her velocity is, or her speed is 20 feet per second, we're going to plug that in. She's landing, so her velocity is negative. This is where it's tricky. They gave us the speed, but since she's landing, that direction is negative. So -20 is the velocity, and then we can solve ln both sides and get our answer. Since it was a non-calculator question, I'm just going to leave it t equals ln of 2/17 over -2 seconds, the best I can do. Okay, so we get a point for this first one and then a point for the second one. Now if you didn't put -20 but you solved it correctly, you'd probably get that point. Okay, so score it out of 9 and make your corrections. And then for number 4, this one's a good one in understanding the difference between just the slope and then solving a differential equation. So A wants the slope of the graph at x is 1, which means we're going to find the derivative at x equal 1. They gave us the derivative because derivative means slope. So all we're going to do is plug in x is 1 and get a half. You get a point for that part. B wants us to write the equation of a tangent line at x equal 1 and then use it to approximate a value close to 1. So the first thing I'm going to do is just write my tangent line equation. We already know the point they gave us, 1, 4. We already found the slope is a half, so we can come up with that equation immediately. You get a point for that. And then if you go and you put in 1.2, now again, it's a non-calculator question, so if you would leave your answer like this, that's fine. I would remember the way v equals for approximate, okay, and you get a point for that. Part C wants us to find f of x. Now this one's a little tricky because we have to make sure we go through and figure out which we want, the positive or the negative square root. So let's first go through, give yourself a point if you separated correctly. If you don't do that separation, you don't get any points, okay? So separate correctly. There's this half here. Keep it away from what you're solving for, okay? Because that really causes issues in some problems. And then integrate the left side, give yourself a point. And then on this one, integrating the right side and the plus c gets you 1 point. And now I'm going to multiply by 2 to get y squared equals. I don't get any points yet. Then I'm going to plug in that point given 1, 4, and finding out c is 14 gets me another point. And then they want us to find f of x. So sometimes in our book we were able to leave it, y squared equals. They want us to actually find f of x. So we have to figure out which would contain the point 1, 4, if we had a positive square root or a negative. So you want to plug it in, see what you'd get. It's the positive square root, so you get a point for that. Okay, so that part was 5 points. And then D, 1 point, use your solution from part C and evaluate. So your question might be, well, what if you got the wrong solution? I believe you should give yourself a point then for part D. Use your wrong solution and plug it in. Now the problem is if you left plus or minus, you're going to get 2 answers.